Welcome Algebra 2. Today we are going to go over dilations. Now, kind of a quick review is when we talk about, we're going to be talking about dilations, which dilations just means when a compression or a stretch occurs. And what that means is when a compression occurs, you can think of it as your function getting wider, or it's getting closer to your x-axis. You can think of it as a stretch when it's getting thinner or when it's getting closer to your y-axis. I'll explain a little bit more of that. This is just notes of what we did in class. A compression, we're multiplying our output by a number, let's say a, that's between 0 and 1, and it's going to be a stretch when we're multiplying the outputs by a number greater than 1. All right? So let's put that there. So if we look here, this is our parent function. This is y equals the square root of x. Now, if you notice here, this is our new dilated equation. This was multiplied by, I don't know, some number. Now, we can kind of think about it. It's getting closer to the y-axis, so we can kind of already think of this as it kind of being a stretch. But even if it's hard to know what it is, we're going to solve it. So what it is we're multiplying our outputs by some number. And so the way I'm going to think about this is if we're going to write down our parent function, well, the next thing I'm going to do, I'll put it right up here, is I'm going to write y equals a times the square root of x. So we're multiplying a times the square root of x, the outputs. We want to find out what a is. So the next step that we're going to do is we're going to look at our parent function here, and we're going to pick a point. Well, I'm going to pick this point right here because I can tell that it intersects it right there when x is 4 and it looks like your y is 10. So I'll put this point here. So when x is 4 and my y value is 10. Okay? Now what I'm going to do is I'm going to plug in x for x and y for y because we want to solve for a, so we need to pick a point that will give us a y value and an x value, and we always pick the point that's on our new stretched or compressed function because this is the equation we want to find. So let's go ahead. 10 is going to go in for y, so we're going to get 10 equals 2. We're going to get a, the square root, and then we're going to plug in 4. All right? Well, that's just going to be 10 equals a. All right, it's a times the square root of 4. What's the square root of 4? Well, that's 2. Perfect. So now what do we do to undo multiplication? This is a multiplication sign. Well, we just divide by 2. So we're going to divide by 2. And finally, we get that a equals 5. So a equals 5. There it is. It's that simple. We just solved for our dilation variable. So now our equation, I'll write it over here, is going to be 5 times the square root of x. And it's a number greater than 1. Right here you see it's 5. So a is 5. It's greater than 1. Therefore, we know that a stretch occurred. It was a stretch. All right? This is an example of how dilations work. Let's go over to this one here. Our parent function is x squared. All right. I'm going to go ahead. You can obviously tell that this was stretched. It's getting closer to the y-axis. And if we look up here, we said that a stretch is something that's thinner. This came from you as a class. And so here, it definitely got thinner than from the solid dark line. All right. So we just need to find what number it was multiplied by to get us this dilation. So we're just going to rewrite this as a times x squared. All we do now is we're just going to pick a point. So let's pick, I guess we'll pick this point right here. All right, we picked that point. It looks like the x value is 2 and the y value is 12. So 2, 12. All right, so now we replace. We go to our equation. We're going to get 12 equals a times, and we're going to plug in 2 in for our input, 2 squared. So 12 goes in for our y, which is why we got the 12 here. And the 2 goes in for our x, which is why we put the 2 in here. All right, so if we go to solve that equation, we're going to get 12 equals a times 2 squared is 2 times 4. We divide 4 to both sides. So we're going to get a is equal to 3. Yeah, so now we have our equation is 3x squared. Because all we're doing is just taking our 3 and now finally plugging it back in for a. And we know a number greater than 1, if our a value is greater than 1, it's a stretch, it's getting thinner, and we kind of saw that in the graph that it was, and this helps to confirm it. Okay, now we go over here. I'll go ahead and try doing these on your own and see if you can do it. All right, welcome back. Hopefully you got a chance to do it on your own. This here is just a linear equation. So now I'm going to write write it as y equals ax. I want to find my a value. We're going to pick a point on our new function right there. It's 1, 3. So my value is 1, 3. All right, and now I just plug in the value for x and y. So we get 3 is equal to a times 1. What's a times 1? That's just a. So a is equal to 3. So our equation is just going to be y equals 3x. And if you notice, this 3 is just telling us our slope. So our dilation is actually really just telling us to find the slope, the new slope of our equation, because the slope now has changed. And that's another way to think about dilations. Here in this next one here, we have y is equal to the absolute value of x. We can tell it's compressed because if you notice from the dark line to the dotted line, it's getting wider. It's getting wider, which is what we said here. So we know the number should be between 0 and 1. All right. So I'm going to go ahead and write the equation up here. Y is equal to a times the absolute value of x. We just pick a point. So let's see here. All right, it looks like this point here is a good one to choose. The point that I chose was 5, and then my y value it's 5, and then my y value is 4. Okay? It's 4. So, there we go. That's 5, that's 4. Perfect. All right, this is my x, this is my y. Now I just plug it right on in. So my y value is 4, so 4 is equal to a absolute value of 5. Well, the absolute value of 5 is just 5, so we get a times 5. What do we do to get rid of the 5? Multiplication, we divide. So we get that a is equal to 4 divided by 5. Perfect. So now we just plug that back in for a. So we're going to get y is equal to 4 divided by 5 times the absolute value of x. Or if you want to find out what that is as a decimal number. So let's see, 4 divided by 5 is 0.8. So we can also write this as y is equal to 0.8 times the absolute value of x. And if you look back up here, well, a compression, something that gets wider, should be a number between 0 and 1. So if we go back down here, our number is 0.8. It's between 0 and 1. So it's definitely a compression. It got wider, and we found out what it was, which was this new equation here. And that's it in terms of finding dilations.